So this is our question, and this is a really interesting question because what happens is this requires MOT, molecular orbital theory. So it states that if electron is in antibonding orbital, the bond order decreases, and if it is in the bonding orbital, the bond order increases. And what is given to us is a complex K4ZnCN4O2. Now you will realize that O2 is a ligand which we have rarely seen in coordination compounds, but here it's given. So it is told that this is oxidized to K2, and inside it's same, the ligands are same, O2 twice. Then here you'll realize that the coordination complex has -4 here and -2 here. So in fact it has been oxidized. Then we will see that here is -4. Zinc always has +2 because it has D10 S2 configuration. When it needs to oxidize, D10 and S0 will be favorable because it won't disturb the stable D10 configuration, which is fulfilled with electrons and they're paired, so it's very stable. Then the remaining option gets to O2. Then we consider it O2 as X, and then +2 - 4 + 2X equal -4. Then this gets cancelled. X comes out to be as -1. So O2 has -1 here. And then here if you solve it, -4 + 2, and the first option is wrong because zinc cannot be 4+, never, because D10 is very stable. Then here by solving we can see that O2 has 0. Then if we see O2 by molecular orbital theory, which was discovered because oxygen was found to be paramagnetic, but according to valence bond theory it was not paramagnetic, but here it is. So here it's sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, and this has 16 electrons, so nature prefers symmetry. 2s is divided into these, 1s is divided into these, and 2p is divided into these. So first we have 2 sigma 2p, which has 2. Then we have pi 2px equal to pi 2py, and then we have the pi star, which is the antibonding. So 1 2 3 4 5 6 7, 14 electrons are filled now 15 and 16. Now here we realize this is pi star 2p and pi star 2py. So you can see the electrons which are between bonding of O2 and O2, which is oxygen and oxygen, these are from pi star. Now star represents anti-bonding. Anti-bonding makes the bond order weak, and we can realize earlier it was -1. So if we add one electron here, then the bond order of O2 will decrease because it is an anti-bonding orbital, and paramagnetism is 1 year earlier. Then later, after changing it from -1 to 0, we can realize in pi star it will be this. So paramagnetism has increased and bond order has increased because from anti-bonding we have removed electron. So the correct option is paramagnetic moment increases.